Hello everyone, my name is Hari Krishna. I am teaching physics. I am working since 2015 and have produced many ranks in IIT and Neet coaching. I will discuss the topic, what is the difference between the linear and rotational. The linear motion and rotational motion. This is the linear motion and rotational motion. So, in the linear motion, generally if you consider one particle or one object, this object will move initially with u, with a velocity u at time t equal to 0. Now, after some time, the particle will be having some velocity v. By the time this object will travel a distance d, this object will travel a distance d. Here time taken is t. Time taken is t. Now, if you consider equation here, in a particular time the distance travelled is d. Okay. Now, whatever the distance travelled in a time t has speed, that we will consider it as speed. And if you take displacement by time, if you consider, you will get it as velocity. Between the displacement and distance, if you see, initially the particle is at this position, it travelled in this form 1 meter distance and it travelled down for 1 meter and again it came back to 1 meter. So, the length of the path is 3 meters. So, what is the length of the path? Length of a path is 3 meters. Okay. So, this length of the path is nothing but distance. This length of the path is nothing but a distance. So, this is the final point. So, if you draw a line from initial to final, this is nothing but a displacement. This is nothing but a displacement. Okay. Now, the difference is total length of the path travelled is a distance, and from initial point to final point, direct line if you draw, that we will say it as displacement. So, how much time it taken? Assume it taken 3 seconds. Okay. Now, here in the speed, if you take, the total distance travelled is 3 meters upon total time taken is 3 seconds. So, speed will be coming 1 meter per second. But in the velocity, if you take, the displacement travelled is 1 meter only, because from initial to final directly if you draw a line, if this is 1 meter, automatically this also will be 1 meter. So, this initial position to final position displacement is what? 1 meter upon time taken is 3 seconds. So, therefore, velocity 1/3 meter per second. 1/3 meter per second. Now, if initially from rest, we will take initial velocity as 0. If this particle is starting from rest, we will take it as 0. So, when time t it reaches to this, we will consider it as v. If initially it is not starting from rest means, we will take it as u. Okay, this is in the linear motion. Then what about rotational motion? In rotational motion, we have to consider one axis. Without axis, we can't say the particle will be in rotation. For suppose, observer is seeing from this point. Now, one particle is there at this position. Initially, observer will see this is at this position, the distance, let's say r. Let's say r. Now, this particle, after some time, this is equals to 0. After some time, this particle will be traveling like this. After some time t, the particle. Now, with respect to this observer, the particle will be at this position. The particle will be at this position. So, how much it turned? It turned an angle theta. It turned an angle theta. Okay, from initial to this final, it turned an angle theta. This theta, we will say it as angular displacement. This theta, we will say it as angular displacement. Here directly initial to final, if you draw a line, this we will say it as linear displacement. In this we will say it as angular displacement. So, here angular displacement time taken, we will take it as angular velocity, that is omega, angular velocity. Okay, that is angular velocity. So, it rotates with an angular velocity omega. Here this we will linear velocity. Here this we will say it has linear velocity, and here we will say it has angular velocity. This angular velocity, how we will write? Theta by t we will write. Theta by t we will write. So, the theta we will take units as a radian. Here units, if you consider, these units will be radian per second. Radian per second. If it rotated 30 degrees, means 30 radian per second we will consider. So, this is angular displacement. By time we will consider it as angular velocity. So, here linear displacement by time we will say it as linear velocity. Now, if you in this case if you see here, initially it is having a velocity 0, after some time it is a velocity. So, if velocity is changed in a particular time, that we will say it as linear acceleration. Rate of change of velocity. Rate of change of velocity, which is nothing but velocity change means what? dv, that is nothing but v minus 0. No, here final, this is final, this is initial. So, always change in velocity, anything change we will consider it as v minus v initial. Initial it is 0, final it is v. Change upon time taken, change in time is what? t minus 0. These we will say it as acceleration. These we will say it as acceleration. In this linear, these we will consider it as acceleration. Then in rotation, initially if particle with respect to this axis, none of this with respect to this axis means observer is seeing from this position, the particle is rotated like this. So, that we will consider it as a rotational motion. So, this here observer will see. So, observer with respect to the observer, the particle